Next, we'll hear from Gacheng Zha, who also goes by Greg, with Coflow jet wind turbines. Gacheng was voted most likely to offer a wind turbine in exchange for a favor.
Thank you. Thank you, everyone. I appreciate this opportunity to share our technology and business. Our focus is to develop wind turbines to provide the low-cost wind energy. So energy with a net zero emission is a necessity for global economy and life. We're continuing to develop economy. We need more energy. So wind energy as a clean energy must be increased dramatically to satisfy 2050 carbon neutral target. The U.S. Department of Energy, the target by 2050 is 35% electricity should be from wind energy, represented by the blue color here. But what's our status today? We only have 7%. So you can see it very light blue. So we have a long way to go. We are at the early stage of enormous wind energy expansion. So what's the problem of the wind turbines today? One is that poor performance at the low wind speed. It doesn't generate much power when the speed is low, so many area cannot use wind turbine. The other is the overall lifespan is still too short, even though it's 20 to 25 years. That's still just too short from economic point of view. So people go large wind turbines and trying to get more energy, but very expensive manufacturing large wind turbines. So all this make the levelized cost of wind energy still too high. Here you can see the wind turbine size evolution. So today's wind turbine is offshore turbine is almost like as high as the Eiffel Tower. So what's the solution? We provide a Coflow jet blade as a solution, which is unique and superior. By embedded fans inside the wind turbines, we suck in small amount of air near trailing edge, energize it, and eject tangentially near leading edge. This tremendously changes the aerodynamic performance, increase the efficiency in the power output. So we already have 11 patents issued based on 18 years of research funded by government. We already received $2.5 million from the government. So first, the benefit of the Coflow jet wind turbines is that we can increase the engine turbine power output across all wind speed. In particular, we are interested in low wind speed. We can use a higher angle of attack with a higher lift coefficient, more power output. But conventional turbine, when you go high angle of attack, they stored like this one. The spaghetti flow structure will not generate power when they are stored. But Coflow is very clean, and we can increase the power, average power by at least 20%. In other words, capacity factor can be increased by 20%. We can also reduce the lower wind speed limit from 6.7 meters per second to 5 meters per second. This can enormously increase the wind turbine usage areas. The second benefit is that we can increase the inner span of the turbine power output. The current turbine is all cylinders shape there. They don't generate lift, they don't generate much power. Using Coflow jet, we can substantially increase the lift and the power there. The third benefit is that we can expand the usage of downwind turbine, which has the advantage of the blade is bending away from the tower to avoid striking. So this will allow us to reduce the mass and the manufacturing costs by 25 to 30%. But downwind turbine has the issue is that the blade will cross the tower wake in every rotation, which will generate fatigue load. Using Coflow jet, we can remove this fatigue load. So overall, this advantage will allow us to reduce the levelized cost of energy at least by 30%. And we can also go very large turbine size, for example, 20 megawatts, and which does not exist today yet. So the market size is about 100 billion this year, and expected to be $2.2 trillion in 2050 with an 11% annual growth rate. Our revenue model is 60% will be from patent licensing, 20% from engineering, consulting support, and 20% from software licensing. We expect to have $837 million in 10 years with a 2.4% market share. So our potential customers or competitors or partners could be OEMs like Vestas, Siemens, GE, or energy majors like BP, Shell, other companies. So at this time, no other flow control technology shows sufficient benefits to be used on wind turbines, except the Coflow jet. Currently, we are in discussion with one energy company for potential investment and development. So the round A ask is $6.5 million for 2 years to demonstrate 30 kilowatt small downwind turbines, and commercialization will start immediately, and we'll raise the TIO from 5 to 8. So here's our technology team. So this is myself, and Dr. Ren is the chief engineer. Don is a retired Boeing engineer. Patrick has both technology experience and business experience. So that's the technical team on the left. On the right is the business team led by Dr. Johnson. He's also business professor at the UM, and Renee, Nancy, and David are all very experienced. I myself is a professor at the University of Miami. My background is mostly aerodynamics and aerospace engineering. So we already received $2.5 million. We welcome investment, collaboration. Let's work together to provide low-cost wind energy, and we want to get more with the wind. Thank you.
Thank you, Kacheng. Let's open up the Q&A portion. We have a question. Do you think about the end of life of those blades? How can we facilitate the recyclability of the blades?
We expect the lifespan will be increased at least by 20%, so to 30 years. Recycling, we are not thinking enough yet, but we do know that there are people working on that field. We would appreciate their work and work with them.
We have a question in chat from Tamiko. Coflow, what sort of technology proof of concept has been demonstrated so far?
We have done that in the wind tunnel testing. You can see that here. I didn't put the results. We do have a lot of results. We substantially increase the lift coefficient, stall angle. It's basically stall-free and reduce the drag.
We have a question from DC Balter. What's the business model? Do you plan to sell turbines or license the technology to existing turbine manufacturers?
We plan to do the IP licensing as the major business model, and also engineering consulting, because we have the experience, design, and test this, and software. We have very specialized software for Coflow jet. But we are very open to work with OEMs and to work together. But for now, IP licensing is the primary model.
We have a question from Rob Tucci with the Texas Halo Fund. What is the projected cost of production of these blades interim of a delta over current blades?
The cost will be reduced because the overall blade, in particular, we are more interested in going to the downwind blade, so it will be lighter, and overall manufacturing costs will be reduced at least by 25%.
Question from Jim Allman. What are the problems with downwind turbines? How does your technology address these problems?
Advantage of a downwind turbine is that we can avoid the blade striking the tower, but problem is that blade has to cross the tower wake. I don't know if you know what is the wake. You can think about the wake behind the boat. Every time the blade rotation passing the wake, it will experience a fatigue load. Using Coflow jet, we can remove this fatigue load, and so that we can have a long lifespan of the blades.
We have time for one more question. With more moving parts in this design, what are your thoughts regarding the ongoing maintenance frequency and costs?
The moving parts is a very reliable one. Actually, most of the HVAC fan will be usable for these fans, but we want to make a special design, but the technology overall is very mature. So we are talking about a very low pressure fan, very reliable. We usually put the HVAC fan in the building for 20, 30 years. It doesn't break. Similar things will happen for this wind turbine, and low maintenance.
Thank you very much, Kacheng and Joseph, joining on the Q&A.
Thank you. Thank you very much.